Welcome back to the Professional Java Development and Test Automation Skills program. I'm John Ferguson Smart, and today we'll be learning about a concept that you're probably already familiar with, but one that I think deserves a little more attention: polymorphism. We're going to look at what we mean by polymorphism and the different ways it can be implemented in Java. But more importantly, we'll have a look at what polymorphism means when it comes to writing cleaner and better code. But before we start looking at the code, let's think about what we mean by polymorphism, or more precisely, what aspects of polymorphism we want to use to improve our code. Now, polymorphism is essentially the ability of a class or a method in Java to have several different implementations, each of which behaves differently. As we'll see, this can happen in a number of ways, particularly through abstract methods and inheritance, and also through interfaces. The simplest form of polymorphism is simply inheritance. For example, a dog and a cat are both animals. So we could say that the dog and the cat both extend the animal class. In this example, for example, we've got a dog called Fido and a cat called Felix. Since both dogs and cats are animals, they can both go into the list of animals just fine. So we can create a list of animals and we can add Fido, we can add Felix, and the animals list doesn't know any different. But the real point of polymorphism is not that you can create a list of dogs and cats in the same object, but that dogs and cats behave differently. Now suppose we want to record complaints about it coming from our animals. Now when animals go to the vet, they complain. So we might want to record their complaints. So we say animals can complain. We put this in an abstract class. Now the animal class is an abstract class, and we create an abstract method that needs to be implemented on every concrete class that extends animals. So in the case of the cat, a cat complains by meowing. A dog complains by growling. So now suppose we have a vet assistant whose job it is to record the animal complaints. The assistant will record each animal complaint, but won't need to know what sort of animal it is. This makes the code a lot more cleaner and generic, as we can see here. Let's see all of this in action. First of all, I'm going to check out the tutorial 3/start branch. Then I'm going to go into my IDE and we're going to have a look at what new classes are available. When you open up this project, you'll notice that in the domain package, we now have a cat class. Now the cat class is fairly identical to the dog class. It's there mainly so that we can experiment with polymorphism. Let's add a new test class that experiments with the idea of creating a list of animals and adding cats and dogs to this animal. I'm going to create this new class in the domain package, and I'm going to call it when collecting animals. In this class, I'm going to add a test. This test is going to illustrate that if we create a dog and a cat, we can add them to a list of animals. So let's have a dog called Fido, and we'll have a cat called Felix. Now we want a list of animal. And now we notice that the animal class doesn't exist, so let's create the animal class in the domain package. And now we need to add Fido and Felix to this list. And we'll see that the compiler is complaining because the dogs and cats are not animals yet. So let's make a dog extend animal. And similarly, we're going to make a cat an animal. And we can check that the animals list does indeed contain Felix and Fido. Now we'll import our humcrest matcher, and we'll import the hasItems method from the humcrest matchers once again. Now if we run this, it should pass. So what have we done here? We have dog and cat, which are now animals, so we can add them to our list of animals, and it won't complain. And as far as the list is concerned, it's just animals. It doesn't really know whether it's dogs or cats at this stage. Now let's see how we might implement the different ways that dogs and cats complain. First of all, I'm going to add a test that illustrates how a dog complains. Now, a dog complains by barking or growling. We're going to say a dog complains by growling. And our test will simply check that Fido the dog, when he complains, he will growl. So we say assert that Fido, Fido's complaint is a growl. Now, of course, the method complaint doesn't exist, so we need to create it. So let's create it in the dog method. The complaint method should return a string, and there now this should work. Now I'm going to write another test that checks how a cat complains. Now a cat complains by meowing. We're going to create Felix the cat and check that when Felix complains, he meows. So Felix's complaint is equal to meow. Once again, the complaint method doesn't exist, so we're going to add it to the cat. And once we've added this method to the cat class and got it to return meow, our test should now pass. This code contains duplication between the cat and the dog. We want to refactor this so that we don't have this duplication. So what we're going to do is we're going to use IntelliJ's refactoring methods. We're going to pull the complain method and we're going to place it not in the cat class but in the animal class. And so now the complain method is overridden. And the animal class becomes abstract. Remember that the point of using polymorphism in this way is so that we can use the common method, complaint, on a collection of different animal objects without having to know about their individual behaviours. In this case, we have a vet assistant who records the complaints of each animal in a complaints register without needing to worry about how the individual animals complain. Let's have a look at how this works under the hood. The first thing we're going to do is create a new test class called When Visiting the Clinic. I want a test that describes cats and dogs complaining to the assistant. We're going to need a cat and a dog. Then we're going to need a complaint register where we record the complaints and a vet assistant to put the complaints into the complaint register. Now, complaint register is just an ordinary class, as is vet assistant. We can use our IDE to create these pretty much automatically. Now that we have our assistant, we want our assistant to be able to record complaints. So we have an assistant who can record complaint from Fido. We also want our assistant to be able to record complaint from Felix. So you'll see our assistant is recording complaints from both cats and dogs. We want our assistant to not care about whether it's a cat or a dog, but just know that it's an animal and record the complaint anyway. So we're going to create this method, record complaint from Fido, dog Fido. We don't want it just to work with dog Fido, so we're going to say record complaint from some animal. And now we see that this passes, or this compiles. So we're going to make an assert statement to check that we get the outcome that we want. And the outcome we want is that the complaints go into the register. So we want a complaint register. We want the complaint register to contain the complaints coming from the dog and the cat. So we say has items, and we're going to have Fido who's going to growl, and we're going to have Felix who's going to meow. A little static import, and we should be good. Now when we run this, hopefully it will fail because we haven't implemented the class yet. So we've got a failing test. We can now proceed to implement the registration. So record complaints from Fido or from Felix what form will this take? Here we're going to use polymorphism through inheritance. We're going to say we have our complaint register and we're going to record a complaint, and we're going to get the complaint from the animal. So here, some animal complaint. This is an abstract method. We don't care about the implementation at this level. All we want to do is get the complaint from the animal, whatever the animal is. Let's go back and run the test again and see if it works. And now the test passes. So we've effectively implemented, using polymorphism, we're implementing this method so that we can record the complaint from any animal, not caring what the animal actually is. So that's polymorphism using inheritance. Now we're going to look at a more flexible approach using polymorphism with interfaces. Inheritance is not the most flexible way of implementing polymorphism. In Java, a class can only have one parent, which limits our options when we try and model complex structures. For example, suppose we needed a vaccination date. We want to manage vaccinations. We could have a next vaccination due method, for example. And since both dogs and cats need vaccinations, we could add it to the animal class. But suppose we need to add support for frogs who don't need vaccinations. Our model no longer works because the next vaccination due method is no longer relevant for frogs. So we end up in square one. Now we could do this with inheritance, but we get a hierarchy like this, which is kind of clumsy. What happens, for example, if we need a method take a bath? Where would that go? If you want to use take a bath on a dog and a frog, that's fine, but a cat, not so much. Interfaces let us model concepts like this in a much more flexible way. Rather than trying to fit every concept into an inheritance hierarchy, we use interfaces to describe specific behaviors. For example, we could have a needs vaccination interface with a next vaccination date due that could be used for both dog and cat, but not for a frog. And we could have another interface, takes bath, which would apply to dogs and frogs, but not cats. Let's see how this works in the code. The first thing we're going to do is give the vet the capability of knowing when the next vaccination is due for the animals that he or she treats. Let's assume that cats need to be vaccinated every year. So we're going to create two dates, today and next year. And we want to make sure that if Felix was vaccinated today, then the next vaccination date should be due in 1 year's time. So we could say, assert that Felix, who has a vaccination date, so Felix's next vaccination date is due next year. So the vaccination date is due next year. Now we'll do our usual static imports and we'll see if we can make the code run. Let's implement the was vaccinated on method. I'm going to implement it for cat to start with and we'll generalize it later on. So we'll also need to implement the next vaccination due date. That's going to return a local date. And now the code compiles, but does it run? Hopefully we're expecting it to fail. I'm running that and I'm getting a failure as expected. We're not getting the date we expect because we're not returning it. Now let's make the code actually work. When we assign, first of all, we need to assign the vaccination date. We'll give it a sensible name. We're going to create a field called last vaccination date. And then when we look for the next vaccination date for a cat, we can say that it's the last vaccination date plus 1 year. And if we run that again, it will pass. Now let's try the same thing for dogs. I'm going to write a test that checks that the vaccination date for a dog is not in 1 year but in 6 months' time, because we're going to say that dogs need to be vaccinated every 6 months. Here what we're illustrating is that with interfaces you can give multiple classes the same interface and then have different implementations for the methods in those interfaces. So we have cats which are vaccinated every year, whereas dogs are only vaccinated every 6 months. Let's start by implementing the was vaccinated on method for Fido the dog. So we're going to say Fido was vaccinated on today, which this bit will be similar to the cat implementation. So we're going to store the vaccination date. And we'll just create a local field out of the last vaccination date. We can do this with fairly easily with IntelliJ. And next we're going to have a similar assert, except that we're not, instead of asserting that the vaccination date is expected to be in 1 year's time, it's going to be in 6 months' time. So assert that Fido next vaccination due is equal to in 6 months' time. Let's implement next vaccination due with a minimum implementation just so it compiles. So we're just going to get it to return a local date, but just return a null value, and then we'll run the test and make sure it fails as we expect. And once we're sure that the test functions correctly, we can implement the next vaccination date properly. So it will be the last vaccination date plus 6 months, as we said for dogs. And if we run this again, we should be good. Now we have a was vaccinated on and a next vaccination due method on both cats and dogs. We can extract the needs vaccination interface to make this a little bit cleaner and more flexible. So if we're using an IDE like IntelliJ to refactor it, we can refactor a selected number of methods. So those two methods that we're interested in was vaccinated on, next vaccination due, and we're going to extract that into the needs vaccination interface. So now we can see that in the test we've replaced the dog and the cat references by needs vaccinations object. But at the moment we've only done it for dogs, so let's do it for cats as well. So as well as extending animal, we'll say that the cat also implements needs vaccinations. And since the method's already there, we don't need to do anything else. In our test, we can now just replace the reference to a cat to needs vaccinations. And we're done. In this module, you learnt about polymorphism. We saw how to use polymorphism to implement the same method with different behaviors in different classes, and how this can make your code cleaner and more elegant. We saw that you can use polymorphism using inheritance, but that inheritance can become quite clumsy when the graphs become a little bit larger or more complicated. And we saw how polymorphism using interfaces provides a very nice and elegant solution to that problem by giving you a lot more flexibility about how to define the behavior of your objects. This is John Ferguson Smart signing out until next time.